Hi everyone, welcome to this episode of Keipert Labs. In this video we're going to be talking about neutralisation and safety. So thinking about how we can use the principles of chemistry to keep ourselves safe in the lab, and also thinking about the broader implications for industry. Okay, so remember that in the past that we've talked that neutralisation reaction is an acid plus a base producing a salt plus water. And we've also talked that it's an exothermic reaction, that it's a delta H is negative value. That is, we've got this much plus, we could write plus energy over on this side, okay, to show that this sort of reaction. We also have a slight kind of variation on that you might remember from in the past. Acid plus a carbonate gives a salt plus carbon dioxide plus water. Okay, so there's a slight kind of variation on this thing. So a particular type of base, but where in this case we're producing the additional product of CO2. Okay, so both of these are types of neutralisation reactions. Okay, and so the reason that we're considering this today is that in industry, a lot of the time that we're dealing with concentrated acids. Okay, so acids that are highly concentrated, and we're dealing with large volumes and that are very corrosive. Okay, that is able to burn skin. Okay, and so what that adds up to is a danger. Okay, that when people are at work, whether you are at work in your job or for me at work in my job, that it's important that I can stay safe, and that I can stay well, that I don't suffer any unnecessary injury because of any risky behaviour or anything that's overly hazardous. So we need ways that we can actually, so that we can take precautions, safety precautions. Okay, that you would have this in your work. You know, you might have PPE, personal protective equipment, to wear when you're doing different things. Maybe there are certain chemicals that you are and aren't allowed to use in different jobs, and maybe that they have to think about which alternatives that they would use. Okay, but in the chemistry lab or in industry, often we have to deal with things which are very corrosive, that are things that are acidic. And so we can't, in situations maybe we're not able to avoid using them, and so we need a substance to be able to add so that it can neutralize a spill. So it can neutralize spills, and it can neutralize / treat effluent. That is, say from a factory, anything that's kind of coming out, wastewater that's coming out of the factory that perhaps needs to be neutralized before it, so that it doesn't impact on the environment. Okay, so in industry, probably one of the main substances that we would talk about that is used to perform this job is sodium carbonate, Na2CO3. Okay, it's stable, it's a stable solid. Okay, it's cheap, and too much doesn't pose a safety risk of its own. Okay, because you could imagine how ironic it would be if the substance you added to keep things safe, to neutralize the reaction, actually posed enough of a risk if you used too much. Okay, whereas with sodium carbonate, if you add too much, it doesn't pose any extra harm to you. There's no increased hazard. Okay, so you can keep it around very safely and easily. It's not going to break down or kind of have any safety risks of its own. It's very cheap to use, and then you can use it in excess without any particular harm. Okay, and so, but in the lab, we would tend to use sodium hydrogen carbonate or sodium bicarbonate. Okay. All right. So part of the reason for that is, so some of the things that we consider when we're doing that, we're talking about the speed of reaction. Okay, so we're considering that it reacts very quickly. and so we can be neutralized nice and safely. Okay, that it's good that it's not harmful in excess. So if we use more than we need to, it's not going to pose any extra harm. Okay, it's safe to handle. Okay, I mean, heavens, we use it in our food, so it's clearly not that much of a safety issue. Okay, it's cheap. Again, you can buy it in large quantities, even from the supermarket. For us at our kind of lab level, but it's easy enough to have a larger level. Okay, and it's amphiprotic, so it can neutralize acid or base spills. Okay, so that's really handy to be able to use the one substance and know that regardless of what it is that's spilt, that you can that you can use the same substance for either. Okay, so so it's one thing that we do have to consider is that when it reacts, because we're producing carbon dioxide here, that we do get a lot of bubbles. Okay, and so that can be an issue, or there's something in terms of what we have to account for when we're doing this process. But that's kind of that's not a big deal when you consider what benefit that it has for us in being able to keep us safe, to help us clean up any spills cheaply, simply, and safely. All right, thanks very much for watching. Bye for now.